I work at Spatial Networks. I'm a software engineer, and I want to talk about creating custom nautical maps with open data. So the first thing I did when I was exploring this was went out and found a couple examples of existing nautical charts. Here's three printed nautical charts that I found. You can see they're pretty dense, information heavy, very, very detailed, hand-placed labels, pretty sophisticated lines. So what actually is used to produce this? There's some bathymetry data, contour lines, navigation aids, lots of points of interest, and plenty of custom labels. So why would I want to do this? Because I want a slippy map, not a printed map. And it's free and it's fun. I got nothing else to do, and I like to share stuff. So here's the final map. I'll just show you that I was able to create using TileMill. You can see the depth values, markers, the channel lines, a couple POIs I extracted. So the data that I used to make this came from NOAA, USGS, some data from OpenStreetMap, and the Florida Fish and Wildlife Conservation. I also want to go over the tools a little bit that I use. gdal is a big one that I use. The Geographic Data Abstraction Library, it's a suite of tools to manipulate raster imagery. It's free, you can download it, use it. It's got some really powerful stuff in there. Also use QGIS. It's a cross-platform desktop application for manipulating GIS data. It's not really an alternative to ArcMap, but it is for what I needed. I used it mostly as a user interface for gdal. And TileMill is the big one here. It supports raster and vector sources for actually rasterizing the map, and it's renders using MapNIC, which gives you really nice anti-aliasing and subpixel stuff. Really, really nice. I put the data into PostGIS, which is spatial extensions for Postgres. You get the power of SQL. I know SQL very well, so I'm really comfortable working with that. And it's directly supported in TileMill, which is really awesome. So here's, on the left is the raw bathymetry DEM data that I downloaded. And on the right is the contour lines that I produced from that using some of the gdal scripts. And the next slide will show you the depth labels I was able to produce side by side here. And those are produced from the contour lines. There's a polygon layer as well as a line layer that's labeled on the map. And also there were some points on the map. I picked some navigation aids. I believe this is from the Florida Wildlife Conservation. They have a data set of channel markers and aids to navigation. I just put a slide here to show that. Points of interest, I extracted this from OpenStreetMap. It's data showing marinas and boat ramps in the area. I believe there's some other stuff in there, I can't remember, but I filtered it on the final map. So I also put some custom labels on there, labeling Tampa Bay with the curve label. There's a screenshot on the bottom right there of QGIS where I created the layer. I'm not sure if you can see it, but it's a custom shapefile line to produce the long curved labels. Here's an image of TileMill designing the map. You can see on the right the style sheet language that it uses, Carto, to design the map. And this is the final, all the layers compiled together. Here's a quick example of the style sheet definition for the marker red and green. You can see the filter for the R and the G on the navigation aids. So why would you want to do that? Why would you want to create a map so you can download it to your mobile phone, mobile device, or view it on the web, share it, or delete it? I don't know. Just practice, I don't know. So what's missing besides the content for this slide? Probably better data is always good. The data I found was pretty good, but it could always be better. The bathymetry could definitely be better to produce more accurate raster data. So that's it. Check it out. It's up. I actually uploaded that map to the web. You can download it and play around with it yourself. And that's all. Thank you.